Okay, so yesterday we actually learned about the first polygon. What did we learn about yesterday? Triangles. Triangles have how many sides? Three sides. So there's some rules about polygons that you need to know. Go ahead and write down these terms. The first one is that a quadrilateral, although it's a four-sided polygon, there are actual multiple kinds of quadrilaterals. We have a square, a rhombus, a rectangle, a trapezoid, and a parallelogram. In the slides after this, we're actually going to talk about the differences between them. Another term you need to know is actually, what is a polygon? Well, it has to be a closed figure. So that means it has to have two sides. It can't only have, it has to have three sides. It can't have two sides because that would just be an angle. So a polygon is a closed figure with at least three sides, all straight lines, no curves. A regular polygon is a polygon that has all sides and angles equal in measure. All right, so equal is the key there, guys. All right, so it's going to have the same measurement sides and same measurement for each one of the angles. All right, so now let's look specifically at our quadrilaterals for a minute. Okay, so we said that there's different types of quadrilaterals. The first type that you need to know, and this will be matching on your quiz and test, is a trapezoid. A trapezoid is quadrilateral with one pair of parallel sides. Okay, and we mark that sides are parallel using arrows to show which sides are parallel. So little block arrow figures, okay? So remember, parallel sides never intersect, right? Right? They never intersect. All right, and then a parallelogram. What's different about a parallelogram? How many pairs of parallel sides does it have? It has two. Okay, so now we use one arrow to show one pair, and we use two arrows to show the second pair. So it's clear, it's obvious which sides are parallel to each other. All right, so parallelogram is a quadrilateral, so still four sides, has two pairs of parallel sides. All right, next set. Okay, so now we have rectangle, square, rhombus, these three types of quadrilaterals. The first one is the rectangle, and it is a parallelogram. You're going to see that all three of these are parallelograms because the only criteria there is it has two pairs of parallel sides. Well, all of these figures have that, all right? But here's the difference now. A rectangle has four right angles. A square has four right angles and four congruent sides. So not only are the angles right angles, but now all the sides are congruent, and I show that by marking dashes through the sides to show that they're equal. Now a rhombus has four equal sides, okay, but no right angles. So you've got to know the difference between them, and if you're given clues, like we'll see in the next slide, you have to be able to identify what type of figure is being described. All right, so now let's look at the example that it gives us. Sketch and classify a quadrilateral with opposite sides parallel. One has a side length of 3 centimeters and another has a side length of 1 centimeter. So you have 5 choices. Which one of those quadrilaterals is it describing? Go ahead and draw it and label your sides. It's not a rectangle because the instructions do not say that this figure has right angles. That is important for a rectangle. So the only other figures it could be is a rhombus or a parallelogram. But it's not a rhombus. Why? Because are all the side lengths the same? No. It's a parallelogram. And why would I label top and bottom or the 3 centimeters instead of the sides? Because they're longer, right? Yeah, so just make sure that when you draw these figures on your homework, make sure you make the longer side with the bigger measure. All right, it seems kind of, more or less obvious, but you'd be surprised. Okay, so just make sure that you draw it that way. All right, so let's do another one. Sketch and classify a quadrilateral with 4 right angles, 4 congruent sides, and lengths of 2.5 centimeters. Both pairs of opposite sides are parallel. Go ahead and do that one. Okay, so we know that yes, the 4 right angles and the 4 congruent sides form a square. But guys, you've got to have the symbols on your figure. If all you have is a box, I'm not going to give you credit. You have to actually show with your symbols that it is a square. All right, so that was good. All right, so now let's talk more about polygons. I'm not going to take a whole lot of time for you to write these in your notes because they are right there in your book. But you do need to write what I have highlighted. A triangle has 3 sides. A quadrilateral has 4 sides. Pentagon has 5 sides, and a hexagon has 6 sides. All right, I'm not necessarily concerned with them being all the same measure, okay? They don't have to be. You're going to see in a minute that polygons can take all different forms and shapes and sizes. But we have to count the sides, and they have to be straight line segments. All right, so now let's look at the next ones. Heptagon has 7 sides, and an octagon has 8 sides. I want to add in 2 more. A nonagon. Yep, you heard me. A nonagon. I think there might be a dash in there. But a nonagon has 9 sides. And a decagon.
What do those look like, Tom?
Decagon. 10 sides. Well, you just basically draw a figure that has 10 sides. All right, so nonagon and decagon, you do need to know those 2 as well. All right, so classifying polygons, that is it for that one. So now let's look at, okay, this is what your homework's going to look like. They're going to give you different figures, and you have to tell me, is it a polygon, yes or no, and why? Okay, so if it's not, you have to tell me why not. If it is, you have to tell me what kind. All right, so here, let me find, well, where'd it go? There it is. All right, so the top left one, is that a polygon, the top left? Why not?
Because it only has straight sides.
Yeah, because it has curves, so we just say no because it has curves. What about the top left one, the arrow? Yes or no? Does it have all straight sides? Do they all connect? Yeah, so it's a polygon. It's a weird looking polygon, but it is a polygon. Now I have to figure out how many sides does it have. So I have to count. 1, 2, 3, 4, 5, 6, 7 sides. So it is a heptagon. All right, I want you to fill in the bottom 3. Are these 3 figures polygons, yes or no? So just go left to right. Like this is the first one. This is the second one, and this is the third one. You don't necessarily have to draw them, but are they polygons, yes or no? If no, tell me why not. If yes, tell me what kind. What about the first one? What'd you say, yes or no?
Yes.
Yes, what kind?
Quadrilateral.
It is a quadrilateral. Did anybody say rhombus? Anybody say rhombus? In the last class, a couple people said rhombus, and I would agree with that, except there aren't really the dashes to show that the side lengths are equivalent. You know, you think it looks like a rhombus, but is it really? So just say quadrilateral. That would be fine. What about the second one?
No.
Why? It has those curved edges. Okay, that's why. What about the third one?
Yes.
What kind?
Pentagon.
Pentagon. Who got those right? Did you get them right? All right, very good. Okay, so that's how we classify the polygons. Now let's find the sum of the angle measures. Okay, so if I'm looking for the sum of the interior angle measures of polygons, I have a formula to follow. N minus 2 in parentheses, so I do that first, times 180. So you take the number of sides in the polygon. You have to know it. If you don't, then you're not going to get these right. You have to know how many sides are in each polygon. You subtract 2 and you multiply by 180. So look at the first one, a heptagon. How many sides are in a heptagon? 7. So 7 minus 2. Okay, what's 7 minus 2? So what's 5 times 180? Okay, it's 900.
So that's like the length or the degree?
That's basically if it's a heptagon, all of the angle measures inside the heptagon will add up to be 900. Okay, so 7 angles. Now if it's a regular heptagon, then I can actually figure out how much 1 would be. We'll talk about that in the next slide.
If you divided that by 7,
It would give you 1. If it's regular, because if it's regular, all of the angles are equal. So like, remember that arrow? Well, all those angles weren't going to be the same, but they will all add up to 900. So it's just different. If it's a regular heptagon, I can find the measure of 1 by dividing. All right, so what about a pentagon? Okay, so what would I subtract in parentheses? 5 minus 2. Why a 5? Because that's how many sides are in a pentagon. So 5 minus 2 is 3. What's 3 times 180? 540. I want you to go ahead and do the last two now. All right, find the sum of the angle measures of a hexagon and a 12gon.
12?
Yep. So anything above a decagon, 11gon, 12gon, 13gon, it actually tells you, so it's kind of simple. It tells you how many sides are in the figure and the actual name of it. Hexagon, what did you subtract? 6 minus 2 times 180. What'd you get?
720.
All right, what'd you get for the 12gon?
1,800.
All right, who got them both? Who got them both? All right, very good. Okay, last slide now. Using a regular polygon. If I know that all the angles and sides are congruent, that they're all the same measure, I can use that information to find the measure, to find the perimeter, and to find the measure of one interior angle. So let's look at this pentagon. Remember, look up here, kind of how I'm showing you that all the sides are equal. We use the dashes to show the sides are equal, and the little arches inside the angles to show that the angles are equal. So the instructions will tell you if it's a regular polygon. In this case, it's a regular pentagon. So it says, find the perimeter of the pentagon given that one of the side lengths is 2 inches. So remember, perimeter is the distance around a figure. So if I know that one side is 2 inches, what do I know about each one of the other sides? They're all 2 inches. So I can multiply it by how many? 5. Why 5? Because there's 5 sides. So what if there was 6 sides? What would I multiply by? 6. So I just changed that number right there. So however many sides are in the figure, that's what I multiply by the side length. So P equals 5 times 2 is 10 inches. Okay? I just multiply how many sides are in the figure times the dimension to get the perimeter. Now, in the last example, can somebody tell me what was the formula I used to find the sum of the interior angles? It was n minus 2 times 180. So how many sides are in this figure? 5. So when I did 5 minus 2 times 180, I got 540 degrees, right? So now if I wanted to find the measure of one angle, since I know they're all the same, I can divide by the number of angles that are in the figure. How many angles are in a pentagon?
5.
So divide by 5. 540 divided by 5 equals 108 degrees. And that's one interior angle. So if they're all the same, the measures are going to be 108. See how I found the measure of 1? Okay, if you understand that, that's everything you need to know for 10.4.